Greetings, fellow programmers. My name is Pavel, and this is a C++ exercise from Chapter 8, Exercise 4, from the Starting Out with C++ from Control Structures to Objects. And this is an addition to the exercise I did last, which was 8.1, where we wrote a program that searched the user entered a number, and we searched whether the number was inside the array. And we performed a simply linear search, basically going from the first value all the way to the last, one at a time. This is gonna be similar, except we'll be still performing the search, but they want us to perform a binary search. And in order to perform binary search, you need to have a sorted array, and they want us to use the selection sort to do the sorting. So in this exercise, basically, we'll practice some arrays, how to search them, how to sort them, using binary search and selection sort. Alright, so let's include our library, IOStream, and let's using namespace std. It's gonna be our standard, and I'm gonna declare a constant, just like with the last video. It's gonna be the number elements equals 18. There's gonna be 18 numbers in the array, so I want it as a constant. So let's do the this is gonna be the unsorted array, and it's gonna be a simple integer array. And mind you, I'm declaring it in our main method. That way, if I create any other functions, I'll have to pass the whole array into it, and that's what I want to do. I kind of want to demonstrate also how to pass the array into function and how to retrieve it, which you don't really retrieve it because the array changes. It's by default is by reference, so it's passed by reference, meaning that whatever changes you make within any function to that array, the array changes throughout the whole program. So it's gonna be integer called account array, and let's initialize it to just a bunch of numbers. I don't have the account numbers in front of me, so I'm just gonna do a bunch of unsorted numbers, one number only, so they're all distinct. Although it doesn't matter, because if you had two numbers of the same kind, the function, the sorting will still work, and the function will simply return true or false whether the number was found or not. But I'm gonna do just all distinct numbers, and there should be 18 of them, because I just declared the size of the array as 18. 6, 18, 4, and 14. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. So that's 18. That's good enough. It's unsorted. So let's do the input variable, which I'll call account number. Initialize it to 0. And I'm declaring a boolean called found, which I'll assume that it's gonna be found by default. I just initialize it to true. It will be, of course, false if nothing is found. It will be set to false. Now, the first thing I need to do is to sort the array in order to perform binary search. So I'm going to go up here and do prototype, and I'm gonna do a void, because it's just sorting the array. It won't return any value. I'll just call it selection sort, because they want us to use selection sort. Now, like I said before, I have to pass the array into the function. So I'm just gonna pass the integer, it's expected an integer array, and the size of the array is number of elements, which is our constant. So this is the prototype, except I'm gonna copy it and paste it right here, because that's gonna be the same signature for the sort array or selection sort. Now, selection sort simply works the way that you have one number that you compare with all the other numbers. So we need two loops. We need an outer loop which will hold this number, an inner loop which will compare this number with this number, and then this number, and then this number, all the way to this number. And since we are sorting them, we'll be looking for a number that is the lowest. So it comes, so it assumes that the first number is the lowest. It checks this number. No, it's still lower, until it comes here. So what we want to do now, we'll compare it. 2 is 2 less than 1? No, 1 is less than 2, right? So what we have to do is kind of remember where the lowest number is, because that is our new lowest number. So in this case, 1 has an index of 0, 1, 2, 3, 4, 5, 6, 7, 8. So we will have to remember, okay, index 8 holds the lowest number so far. But it still continues to the end. But 1, yes, it is indeed lowest from all of them. So at the end, when it reaches the end, it will go and swap these two numbers. So 1 will be now first, and 2 will be over here. Then we'll move forward to this number. And now we already know that the lowest number is already placed into the correct position, which is now the index of 0. But now we compare this number with all these numbers, and again it comes here. Well, 12 is greater, so it leaves it alone, but 8 is less than 10. So this is our new lowest number. But okay, now 8 is the lowest number compared to 7. Now 7 is the lowest number, so we have to remember that it's 7. And when I come over here, oh, remember over here it's gonna be number 2. So it compares that, and yeah, that is still lower than whatever number is here now. And in fact, it's the lowest from all of them. So now 2 will be placed in the position of 10, and 10 will be placed over here. And that's how it goes all the way to the end. Basically, it takes one number and compares it to the rest. Then it takes this number and compares it to the rest. Then the third number and compares it to the rest, and so forth. One thing to remember, this is the last comparison, these two numbers. So if this is the outer loop and compared to this one, this is the last thing we're comparing. If we cannot compare 14 with anything else, because there's nothing after it. So our outer loop will end with the number of elements minus 1, because this is the last number that we are comparing from the outer element. And it's simply, if this one is lower, then we'll simply swap them, and that's the end of the whole sorting. Okay, so enough for the explanation. Let's just do it. That's the way to kind of better understand it when you actually code it yourself and see how the program operates. So I'll do an integer. I'll call it minimal index. This is gonna be the index of the number that is lowest. So that way we'll be able to remember it and swap those numbers. So like I said, we need a for loop. So it's gonna be for integer I equals 0. We'll start from the beginning. I is less than number elements. But remember what I said, it doesn't go all the way to the end with the outer loop. It's minus 1, because this is the last number that we need for the outer loop. Otherwise it would crash. If it comes over here and it tries to compare 14 with the next number, there is no next number, right? So that's why we have to get minus 1 here. And I plus plus. And now I'll simply assign a variable. I'll call it integer minimal index, and it will be the index of I. I'll simply, whatever number it is that we are comparing, we'll assume that's the lowest, and then we'll simply swap them if it's not. And I'll also create a variable called integer minimal value. So this one holds the index of the number that is the lowest, and this one will actually hold the value itself. So it's gonna be the array that we passed into our function as an argument of the index I. So I, let's say for this number, for 10, I is 1 because it's index of 0 and 1. And minimal value is the array of the index of I, which is the value of 10. So now we can do the inner loop. So for integer c equals 0, c is less than the number elements, and c++. Now in this case we go all the way to the end, because for this number we do want this number at the end. Remember, this loop will hold at the last iteration the index, since there's 18 elements, so this is index 16 and this is index 17, so we are comparing index 16 with 17, but we don't compare index 17 with index 18 because there is none. So we'll simply loop through the rest of these, which is the inner loop, and we'll compare the numbers. So if the array of the index of I, actually the index of C, if it is less than the array, no, not the array, but let's just do the minimal value, because we are capturing the value in the variable called minimal value. But basically, if it is less than the array of I, but like I said, array of I is now being captured in the minimal value, so we can just use that for the readability purposes. So if that's the true, then we have a new lowest number, right? So our new minimal value will now equal whatever the array of C is holding. So this is the new minimal value now, right? Over here, because it's less than the current minimal value. But like I said, we also have to remember the index, so we can swap it. We need to remember the index of 8 in this case for the number 1. So it's gonna be minimal index now equals C, because C is the index that holds now the value of that holds the number that is the lowest from all so far in the array. And in the case of number 1, yes, it is the lowest even when it comes all the way to the end. But in case of, let's say, 8, you know, there's other numbers that are lower, like 3, 5, 6, and so forth. So, but it will find it, and at the end, it will simply hold the value that is the lowest, and it will hold the index of the number that we are swapping, which we can do right now. Swap the values in the array. So I'm gonna do a temporary variable of the integer that will simply hold the minimal value. So in the first iteration, temp will equal to 1 because that is the minimal value. Now our array of I, which in this case would be 2, in this case it's the index of 0 and it holds the value of 2, but we can now assign the new value because 2 is not the lowest number that was found, it's 1. So this array now has to hold the minimal value. Oh, I actually got it wrong. This is correct, but the integer, the temporary one, doesn't hold the minimal value. It holds the index of the starting position, which is the I. So it holds the array I. Okay, so it holds the value of 2. So temp equals 2. Now the index 0 now holds 1. So now the index 8, we can now assign the value of 2 to it. So our array of the index of the minimal index that we captured over here now, so that one will equal to the temp. And that's how you swap them. Alright, you need a temporary variable to hold it while you are swapping it. Otherwise, you would just override it. You still need to remember what the value was and assign it to the new position. So let's test it first. Let's see if this actually sorts the array. So I'm just gonna do for integer I is equals 0, I is less than the num elements I++, and over here we'll do cout and do the account array of I. We will simply output each of the elements or each of the numbers on a new line. But one thing I forgot, over here I need to actually make a call to this function, otherwise obviously nothing would get output at all. This function would never execute if I don't make the call. So I'll call it with the account array, which is the unsorted array at the moment. And over here it should output it as a sorted array. So let's see if that's working. Let's build it. And well, it did not work. What it did is it swapped some of the numbers, but not correctly. And the reason is, I told you that we need to compare two numbers, this number with the next number after it. But if you look at the loop I have here, c equals 0, I'm comparing it all wrong. I'm never moving forward. I mean, I'm comparing the numbers, but I always start from the 0. I never start from the next value after. Like if I holds the value 2 in the first iteration, then c in the inner loop should hold the value of 10, but it doesn't. It actually holds the number of 2 as well, and it goes through all of these numbers the same way. So c doesn't equal 0. C simply equals I plus 1, which makes it the next number in line. So let's try it again. And yep, that's what it was. You have now the sorted array right here. Again, you cannot start from 0 because it's the same number as I, always. You know, you start at the beginning, you're comparing 2 with 2 as the beginning. Then in the next iteration, even though you sort it, now you're comparing with the same numbers over and over again, because you have to keep moving forward, because the first number is going to be sorted by then the second will be sorted, and so forth. So you have to keep moving forward and compare each number with the next number, which basically, if c equals I, the next number would mean that it's c equals I plus 1, which makes it the next number. Alright, so our sort array works, so I'm just gonna comment this out. We don't need that to display, it was just to test it. So now let's do the binary search itself.